I mean, these are clearly some really exciting times ahead, and what a fantastic group to work with. I have to tell you, one of my favorite meetings every week is the one where this team gets together. And I hope you can see that there's this internal team, but there's a larger team at NASA that is working on a number of these things and helping this team, and that there's a larger community too, and there's lots of ways for that community to help participate as well. And let's look like we have a question in for Barb. I have a question about sample contamination process. Is there a strategy thinking about prior sampling contamination, example, collecting the samples we really need or selecting a better in situ site?
Yeah, sure. So the strategy that we are putting together, obviously you've heard that a lot of the Artemis program thinking is already in place in a lot of the architecture. So there's some amount of documenting and understanding what we're already planning to do, and there's some amount of planning for how to do it better and how to get the samples we really need as well. And remember, the point of having the Artemis internal teams is looking beyond just Artemis 3. So even if we don't get our dream samples from Artemis 3, although I'm going to work extremely hard to make sure we do get our dream samples from Artemis 3, we do have more opportunities to provide influence and planning, quite frankly, for getting better and better samples and getting things that we need. We can't, just expect to, one does not simply just walk into a PSR, right? So there's a lot of forward planning that we're going to be needing to do for different environments that we haven't been into, and the specific science that comes from those environments. So yes, your point about contamination is well taken. The contamination knowledge plan, which we don't currently have, but we will certainly share with you when we get it, is going to involve exactly the kinds of things that you're thinking about. Do we bring witness plates with us? Do we expose them on the surface and then bring them home? How do we do that? That kind of contamination knowledge is definitely something that's in our strategy.
Thank you, Barbara. We're still waiting for more questions. I'm shocked that this community doesn't have more questions for you, but as they're coming, here's one from Carly. Okay, great discussion. I worry, however, that thinking is similar to Apollo operations and don't hear anything about the in situ modern tools that have been developed in the last 50 years. Just thinking about the last 2 NASA landers on Mars provides and how astronauts will use them in real time. So Carly, that is a fabulous advertisement for our next LSSW, which is happening pretty soon, June 16th, where we will in fact be talking about modern tools and how to use them effectively with humans on the surface of the moon. So please stay tuned for that. And in fact, if you would like to join us for that, I'm sure we can find a place for you on the schedule as we are putting that together. Please reach out. Would anybody else like to comment on that?
I can just say that we are definitely bookmarking in our surface operations planning the ability to use more complex tools beyond just the types of tools that we saw in the Apollo program. So I can tell you that we are strongly raising our elbows, keeping them up, and reserving space for astronauts to be able to use those tools, both kind of the deployed payloads that you heard Renee mention earlier, as well as tools that would actually give crew members, advanced in situ scientific data. So you've heard from our headquarters colleagues that they're going to be soliciting for those payloads, and we're definitely reserving space for them in the operations plans.
Fantastic. I see a question from Alex Kanalakos. What is the biggest science hardware architecture gap in front of us for Artemis 3? Anybody want to take that?
I can take a stab at that. So I would say, I have a kind of biased viewpoint because I think about sample return as curation lead. But one of the biggest gaps that we have right now is collecting and preserving the PSR samples and the samples that are going to come from very cold places and potentially be rich in volatiles. And so that is a very new area of sample return and science that we're going to be doing here on the moon. And it's awesome and it's amazing, but it is very challenging because those types of samples have very specific chemistries and very specific materials compatibility requirements, and there will be phase changes in flight and things like that. And so we're thinking through all of those different challenges, and we've broken them down into what we hope are manageable chunks. And so we are working on those. So it is a big gap, but at the same time we are rapidly closing it.
Anybody else want to take a crap? Renee, do you have anything to say about payloads?
Yeah, I've been thinking about the best way to phrase it. I mentioned earlier, trying to delta from the ALSEP, surface experiments package, which was had an independently powered base station that instruments could connect to. And so the closest equivalent, I think, in the modern day is a MMRTG. And we're not really sure about what, the availability of MMRTGs and whether or not we can count on that for the next generation of surface payloads. But further is the actual, capabilities of the vehicles in terms of mass delivery to the surface. So right now, at least for Artemis 3, the requirements on the vehicle have a sort of a very limited margin after you account for the mass taken up by the sample return containers and the tools that the crew will use on the surface. So that's something that we're actively in discussion with right now. With SpaceX, who'll be providing the HLS for Artemis 3, and hope to be able to increase that for future missions.
Yeah, and I would just add to what Renee said, the return capability to Earth is also limited in our understanding of the architecture available to us, which limits our ability to return samples and other experiments. So that's a capability that we're also advocating for every day. I know people are in meetings every day advocating for that.
All right, I don't see any, unless I'm missing it. Somebody point to me if I'm missing a question. I don't see any other new questions, but in the meantime, while we wait a few minutes here, would anybody like to talk about the SDT report and how you as a team are infusing that into the Artemis program?
So I'd be happy to cover that one as well. Yes, we definitely see the findings of the science definition team report, which almost all of my fellow internal science team members participated on, being integrated into the plans across programs and across directorates. We have a variety of utilization coordination groups that include membership from SMD, from STMD, from the HEO side of things. And they are constantly looking at the recommendations specific to science to feed the actual mission objectives. So, not just obviously the highest level mission objectives to land and return humans safely, but also counting mission success based on the ability to meet the objectives laid out in that plan. So it's very satisfying to see the results of all of that hard work, which also included a lot of community input to make sure that we are using those as metrics for success.
Anybody else want to comment?
I would echo Renee. It's impossible to overstate the importance of the science definition team report, and especially in terms of driving the hardware requirements for the various hardware elements we have in work right now. And as definitional work has continued on the architecture, it's just that report was exactly correctly timed to have the maximum level of input into the human architecture. So we're very fortunate to have completed it.
Sarah, there's a question here about Starship. That might be something for you or Jake.
Yeah, I was just
Possibly
about
Renee.
to call on Jake for that. Jake, are you on?
Yeah, sorry, getting there. What was the question? Artemis 3 doesn't Starship return to Earth for reuse since Ryan is so limited in sample return? Is Starship an alternative way to get samples to Earth? I think, looking forward after Artemis 3, there could be many different concepts of how we would return mass to the Earth. That option is not a part of Artemis 3. So it's not a way that we will bring sample material home during Artemis 3. I'm not even going to try to speculate at possible options that commercial partners could bring forward for future missions. But part of what we depend on for Artemis moving forward is an ability to look to our commercial partners for their ingenuity, their creativity at solving some of the problems we're going to have. So, I think, John, what you're really highlighting here is our need for our partners to step up and bring solutions to the table when we put RFPs out on the market to try to get those options for what we need to meet the objectives. Like I said in my presentation, start with the objectives. We do the best we can to meet them with the hardware concepts we have in place. And, through partnership, whether it be CLIPS or any of the answers that we see to any of the RFPs we'll be putting out from the exploration side, that's what we want to depend on our partners to bring forward is some of those options.
Right, I am still looking for questions. Nobody has any questions.
Yeah, there's a comment here, Julie, you can probably comment on too. Keeping sample return at initial temperature is key. That is true for many science questions and maybe not as true for other science questions. So that is something that you can see in a little bit in the SDT report, is that yes, ultimately what we want is to pick up volatile samples or any sample at the temperature that it has been at for 2 billion years. That's clearly the best way to look at everything that's been happening to the sample in situ, like the sighting of condensed volatiles. It's not easy to do that. It's not easy to keep something at a PSR temperature the whole sample, the whole way back on the whole sample train. And so I know Julie's team has been, for example, looking at what kind of gas phase chemistry you might expect if you were to return something at a warmer temperature than how it's been stored, how you could maybe trace back from what you returned to what you started with. And the first step in that really is the Apollo 17 core sample that we're just opening in the ANSGA program, where they are sampling the headspace gas that's been stored at room temperature since it was collected on the surface. And so sampling that headspace gas is going to really be important in trying to trace back where that was cited and what kind of gas phase chemistry we could expect if we're not able to, at least initially, return samples at the temperature that they've been stored at for 2 billion years.
Yeah, just to add to that, so my presentation later in the day is actually going to be about some of the testing that we're doing at the Johnson Space Center to look into the effects of temperature changes on samples. So we've actually been doing some work in making some PSR sample simulants that contain some key volatiles, and we are testing those samples by storing them at different temperatures. So from room temperature, which is going to be the sample temperature for Artemis 3, down to -20, which is the storage temperature that I mentioned earlier that the Apollo samples have been, some of the Apollo samples were stored at, and then -85 degrees C, which is probably the temperature we'll hit for the earliest flight freezer we could fly. And then we'll also be storing some at cryogenic temperatures to compare to, like you said, their initial temperature that they were probably collected at or will be collected at in a PSR on the moon. So we'll be able to look at volatile phase changes and compositional changes, also any effects that those volatiles might have on the regolith, any kind of surface alteration, chemical alteration, pitting, textural and morphology changes, things like that. So we're hoping to get a sense of what impact temperature changes have on the sample so that we can have a better understanding of what science to expect from the samples depending on how they're stored after they're collected. So listen to my talk later.
Yeah, and keep in mind too that there's probably some science that's better done robotically, that's better done with capabilities that humans don't necessarily bring to the table, or you can't necessarily sterilize a full human, right? So there may be some science questions that are not better answered by having crew there. So that's another thing to keep in mind.
Renee, do you want to jump back to Alex's question from earlier?
Yeah, so when just to kind of round out the discussion on what are potential science, hardware, or architecture gaps. There's one that I actually forgot to mention, which was recommended in the SCT report in addition to the power solution and the mass delivery solution, which is mobility, surface mobility. So, surface mobility directly affects what science we can and can't do on the surface, and also impacts indirectly on landing site selection. And that's definitely something for Artemis 3 that will be limiting compared to later missions. I believe LTV is on the architecture starting in Artemis 5. So that's something that we have to consider, and that the competed teams will have to consider when working on more specific science objectives and instruments for the Artemis 3 mission.
Oh, and another one popped up from Alex. Besides surface mobility, what concerns do you have that will limit our astronauts from completing science objectives on Artemis 3?
Yeah, so fortunately, while it is limiting when considering the entire suite of science possible on the lunar surface, we are able to address all of the objectives in the science definition team report and in all of the roadmaps, sort of independent of where we go. Well, I shouldn't say all of them, but we can do high priority science anywhere on the moon. And so it's obviously something that has to be taken into consideration, but not something that is necessarily limiting to overall production of science. And I welcome any of the other members of the SDT to chime in on that.
Anybody else?
Kelsey, one thing that does come to mind too is the way that we use humans on the surface and the other things that they are going to be needing to do during EVAs. I mean, is that how do we balance science with all the other things that they need to do?
Yeah, that was one thing that popped into mind when I saw Alex's question too, of Carly's question from earlier, actually, right? Of, we have experience from Apollo and we're taking lessons learned, certainly, but we're now multiple decades later, and what new exciting things have come online. And I think payloads is a great example of this question. So making sure we get those payloads online early enough, not just from like a crew training and sort of launch vehicle integration perspective, but also from an ops perspective to understand how that's going to influence not just sample collection and which samples the astronauts, are going to select to take back home, but also influencing our real-time understanding of the geology around us. So I think, on the science operations side, the astronauts are certainly going to have, us on the ground to rely on to help interpret those data. But how can we train the crew effectively to use those real-time data? How operationally do we bookkeep time in the timeline to make sure that we're reserving adequate space for not just sampling and sort of general exploration and observation tasks, but adequate time to not just deploy instruments, but possibly assimilate that understanding from those instruments into the operations that they're doing real time on the surface? That's a really complicated question, certainly in terrestrial field geology, and for obvious reasons, it's going to be a lot more complicated on the surface of the moon, given EVA constraints. So one thing I've thought a lot about is getting those payloads on board fast enough to be able to accommodate that new and evolving understanding that Carly brought up earlier.
So here's an interesting question. Are there any plans to send human missions to the far side of the moon if certain science endeavors require lunar far side sites? It's not up to this team to decide whether we're going to do that, but would anybody like to comment on the science that we could do on the far side?
Yeah, there's a huge one on the far side that's called the South Pole Aiken Basin. Yeah, exactly. That's, the sample collection from the sample return from the South Pole Aiken Basin has been a priority of 3 decadal surveys now. So a long time running for the lunar community. And that's definitely an opportunity that we need to capture and provide to the lunar community. James knows from the decadal survey that there were some suggestions there. It's definitely a very high priority science objective. So I think it's not necessarily up to us to decide that, but there's certainly reasons.
would also echo that, the concept of a base camp or a central starting location. I talked about this at the first LSSW, that if you want to start doing experiments on the far side and you want to start expanding the reach of our exploration, that stationary power, habitation, infrastructure is super important for enabling long duration experiments on the surface and enabling interesting things like, far side radio astronomy, or even optical astronomy from a central point. That infrastructure is super important for enabling a wide variety of multi-stakeholder objectives. So, that's what we do on the surface really does depend on what the community expresses as its desires and needs are. So.
There's a question here from Clive about whether RTGs will be available for power and data collection for deployed experiments. Kind of already addressed, Renee, but if you want to.
Yeah, I don't know if Brad is still on, but that's something that we've been talking with the SEO office about. It's still a TBD at this point, so not much that we can say.
It's a question about how data collected, the scientific motivation behind that data, and the science story that it presents will reach outside of this lunar and planetary science community. How do we get our message of planetary and lunar science out to the greater world?
Well, Sarah, if you want, I'd like to try to take a stab at that, and I'd be curious what others think. But my feeling is that, in Pursuit, we have to take every opportunity to talk about lunar science, why it's important, why we care. I think there's all examples that we might be able to pull on of how the public at large is or is not aware of what we're doing, and we need to do better. And so I think one way that every single person on this meeting can get involved in Artemis is going out and talking about why, as Sam said, the moon is such a wonderful and amazing scientific and inspirational place. We have an eclipse coming up on Sunday, and we have eclipses that happen quite regularly. And so everyone should use any opportunity that affords themselves to talk to community groups, schools, the person next to you in line at the checkout counter about, hey, why is the moon important? And, I think there are opportunities certainly that NASA presents for talking about the moon in an International Observe the Moon Night later this year. But everyone should take it very seriously that we need to do a lot of heavy lifting to communicate the whys and eventually the hows of what we're doing and how it feeds back to all of us. I know there's a lot of things happening in the world right now that might be distracting, and for good reasons we should be paying attention to that. But we should also be talking about some of the inspirational stuff that we're doing. We're going to be sending friends, colleagues to the lunar surface in a few years. That's pretty exciting. And if you can communicate to 10 people that excitement and they talk to 10 people, we've all gotten very good about contact tracing over the last 2 years. But if you can contact trace that spark of enthusiasm about planetary science and exploration, I don't think we'll have to worry about the future of Artemis as much as we might have to should we not do more communication and outreach. So Pursuit, the opportunities present themselves. We just have to be willing to say yes and go out and do that legwork of talking to the public about why what we're doing is so important.
Awesome. Thank you, Noah. And on that note, I think we will close off this session. Thank you all. Really looking forward to working with this team over the next few years.